Hi, this is Chris, and we are finishing up section 3 of SAT Practice Test 2. So let's take a look at question 19. Here we have a graph that gives us a coordinate, and the question asks in the xy plane above, 0 is the center of the circle, and the measure of angle AOB is pi over a radians. What is the value of A? So this question requires two main concept areas of understanding in order to answer this correct. The first is that we have to understand what is meant by this word radians. So when we see radians, we're going to have to understand what that means as it relates to a circle. And really, it's just a different way of talking about circles. We're used to talking about circles with angles. A full circle is 360, or half of it is 180. And we get used to thinking in terms of degrees. Radians is just a slightly different way of measuring a portion of a circle. So when you see radian, just think that that's representative of a particular portion of a circle. So we can relate radians in a circle to degrees with this relationship here. 360 degrees is equivalent to 2 pi in terms of radians. So another way of thinking of that is that 360 degrees would be all the way around a circle. And if you think of a unit circle, which is something that pre-calc students are certainly familiar with, that's like saying that you have a circle with a radius of 1 unit, and the entire distance around, if you look at it as a length, would be 2 pi, because your formula for circumference is 2 pi r, and if the radius is 1, the entire distance around would be 2 pi. So when we talk about a radian measure, we're really relating degrees to a distance. We're thinking of that circumference of a circle in terms of a length. So that's where we originally get introduced to radians, and let's see how that's going to apply on a question like this. So if they want us to figure out the value of A, which is a portion of this radian measure, we're going to see if we can relate that to degrees. And to do that, we want to look at this triangle here. And for any triangle, if you can create a right triangle out of a portion of a figure given, then there's a lot that we can do, because right triangles allow us to solve for different sides of it using Pythagorean theorem. We have certain triplets like 3, 4, 5, or 5, 12, 13 Pythagorean triplets that we might be familiar with. We have rules and side relationships for special right triangles like 45, 45, 90, or 30, 60, 90. So there's a lot that we know about right triangles that we can work with. So let's see how that might work on this question. By giving us the coordinate, they're giving us the x value of root 3 and the y value of 1, which tells us the two side lengths of this triangle. And let's see if we can somehow use that relationship to figure out a degree measure. So if we were to try to find the hypotenuse of this triangle, we can use Pythagorean theorem, and this would be root 3 quantity squared plus 1 squared equals c squared for that hypotenuse. And that gives us 3 plus 1 equals c squared, 4 equals c squared, and the value of c, or the hypotenuse here, would be 2. So now we have all sides of this triangle, and if you don't notice the relationship, you might check the little cheat sheet at the beginning of the section to see if they tell you a relationship of the sides of a triangle, and if this happens to fit one of those given relationships, which it does. But I highly encourage anyone looking to answer a question like number 19 out of 20, which is a very difficult question. I encourage anyone who's looking to answer this correctly and within the time allotted on the SAT to go ahead and memorize that information, because we should see this relationship of the sides and recognize that this is really, let me color code this a bit, but this is really like saying that you have x times root 3 and 2x for those side relationships, which is true of the side relationships for a 30, 60, 90 right triangle. And that piece of information here, understanding that this angle in question is 30 degrees, is going to be enough for us to then relate it to this degree versus radian relationship. And to do that, we can say that our part over whole relationship of our degree terms is equal to our part, which is the pi over a radians that they're talking about for this angle AOB in question, over our whole for a radian measure relationship here. And in doing so, we can reduce this. This would be 1 over 12 equals pi over a over 2 pi. You can cancel out the pi's here, but a lot of people find it easier on this question to just multiply by the 2 pi so that you have two simple fractions. And when you do that, let's bring that up here, but this will give us 2 pi over 12 equals pi over a. And in this case, we can cross multiply. And so the pi's will cancel when we do that. And you get 2a equals 12. And your final answer of a equals 6 on this. So again, what we're really looking for is an understanding of that degree radian relationship, and then an ability to identify the missing angles of a triangle based on those side relationships. Those are the two key components of getting a really tough question like this correct. Now let's take a look at another tough question in number 20. And this gives the system of equations and reads, in the system of equations above, a and b are constants. If the system has infinitely many solutions, what is the value of a over b? Here, the key is that they mention infinitely many solutions. And really what that means is that after your variables cancel, you're going to be left with a mathematical expression that is true. So here, infinitely many solutions, two things to note. Your variables will cancel, and you're left with something that is mathematically true. So basically it just means that you're left with a numeric expression that is true, and it's always going to allow you to simplify to 0 equals 0. The reason that is so important is because in order for these constants to cancel out, ultimately everything's going to cancel for us to be left with that 0 equals 0 expression. So in order to get that, we don't know what we would need to do to get these x's to cancel or to get the y's to cancel, because we have a and b that are currently unknown. But we do know what we need to do to get these constants to cancel, because these are both known values. So we want to look at this, and as is the case with any system of equations, we want to think to ourselves, what can I do to try to eliminate these values or use these values to cancel each other out? And here we can multiply this top equation by -5. And in doing so, when we distribute that, we'll have -5 ax minus 5 by equals -60. And then the bottom equation we can just copy as is. 2x plus 8y equals 60. And when we combine these, our constants will cancel. We'll be left with 0 on this side. But also, what's important to note is we should be left with 0 on this left side. Each of these should give us a 0 when we go to combine those terms. And that's going to be enough to allow us to create equations where we can find an actual value for a and b correspondingly to ultimately solve this question. So here, let's write out an expression for each of those. So for this first one, we'll start with this expression, -5 ax plus 2x. And what is that expression going to be equal to? So to finish out this equation, it's going to be equal to 0. And that's going to allow us to solve for a. -5 ax equals -2x. You can divide by x to cancel those, and divide by -5 to get that a is 2/5. Now let's do the same thing for the other piece. So here we have -5by plus 8y equals 0. And we can solve for b. -5by equals -8y. Divide by y to cancel those. And then divide by -5 to get that b equals 8/5. Now we can plug in and solve for a over b. So to do that, we just have 2/5 divided by 8/5. And remember, when you're dividing by a fraction, that's the same as multiplying by the reciprocal, or a phrase that a lot of students prefer is keep, change, flip, which is fine. You're going to keep the numerator. You're going to change the sign from division to multiplication, and then you're going to flip that denominator. So here you have 2/5 times 5/8. The 5's cancel, and you get 2 over 8, which we can reduce. And our answer to this question will be 1/4. So although there's some complex math in here, you have some negatives to make sure to keep track of, you have some complex looking fractions, the key skill is really understanding that when you see this phrase, infinitely many solutions, you want to make sure that you understand you're going to be canceling those variables, and you're also going to be canceling those constants to end up with 0 equals 0. Stay tuned, and we'll dive right into section 4.